Hello everyone, I'm welcoming you all once again to this channel. So in today's session of Fortran programs, we will use our do loop to design a square lattice. Let's go. And here, before going to design our square lattice using Fortran code, we will first see what is a square lattice. So here we can see that this is nothing but a two-dimensional Euclidean, like a lattice type, which is in a two-dimensional Euclidean space. And this is one of the two-dimensional Bravais lattices. As we know, there are 5 types of Bravais lattices in two-dimensional. This is one of them. And here what will happen, that this lattice will elongate along x and y axis, like any two axes, as it is a 2D lattice. And along x and y, the lattice constant has to be same. That means, as it has been mentioned here, that a1 is equal to a2, which will also equal to a. That means both this vector, this a1 and a2 vector, will be equal to a, and the angle between those two vector will be 90 degrees, so that it can maintain its square lattice nature. And if these two vectors are different, that means a1 is not equal to a2, then it can be, and but this angle alpha is equal to 90, that then we can say that this is a rectangular kind of lattice, which is also a kind of Bravais lattice in two-dimensional space. So this way we can design, and to design a square lattice which can translate up to certain range, we have to use a kind of transformation vector. So here this vector I have used, that this m and n values will try to elongate this x and y axis up to certain number. So we can make a infinity kind of square lattice also, but if we want to limit our construction, then we can arrange these numbers like up to certain range. So this way we can make our square lattice. So let's go for the Fortran coding part. So here you can see that our program is started with square lattice, and here we have taken some integer type of variable. Those are m, n, and the number of atoms, that is n atoms here. And the real data type here we have taken as ax, ay, bx, by, x, and y. And here what is a, that a is nothing but the lattice constant, that is 1.5 here I have taken. And ax is the vector which is moving along x direction. The x component of that vector is ax, which is equal to a, and this vector don't have any y component initially, so that value is mentioned as 0. And along this axis, that is along y axis, the component of the vector bx, which is 0 initially, but the component of the vector by, that is a. And x and y are nothing but our origin. Now, that's why it is initialized with 0 and 0, and the number of atoms here I have taken is equal to 25. And why 25 I will tell you. And next is, we have to, if we want, we can print first our number of atoms, then any command line, instead of this command line you can write that the square lattice, or you can give your system's name, so that in our in our output we will see this kind of printing output. And next we will try to use our do loop to construct our square lattice. So here the do loop is started with n is equal to 0 to 4. This will tell us about the y axis translation. And then inside this do loop, another do loop is also used, that is do m equal to 0 to 4. This will do the x axis translation part. Next, in the print statement we have written that c, the first this value c will write, like if we want to make a square lattice of carbon atoms, so this c is defined for that atomic number, like for that atom, and this is for carbon. And next is the x axis of that atom, that the x axis is started with origin, so x plus m into ax plus n into bx, and then the y coordinate is equal to y plus m into ay plus n into by. So this is along the component. So the as it will elongate, so it will first take the x component of this y of this point, which will be added with origin. If this is the origin, then this will be like x plus m into ax, where m is the x axis translation value, and plus n into bx, that which is the y axis translation value plus y component of that vector. So this way it will go, and similarly the y component, y axis component will go like y plus m into ay plus n into by. And here, as it is a square lattice, so our z coordinate will be 0. So that's why we have maintained this value as 0. And here we are ending our do loop and ending our program. And also here I have to mention that our do loop is started from 0 to 5, and this one is also started from 0 to 5, 0 to 4. That means 0 to 4 is how many? That means 5 numbers. And here from 0 to 4 is also 5 numbers. So as it is a square lattice, so 5 along x and 5 along y will give us 25. So that's why the number of atoms are 25. So now it's time to execute this program. So I'm going to execute this using this online compiler. So here I am running this program. So you check here that it is showing that 25 numbers of carbon atoms are here. So these are the carbon atoms, and this is their coordinate. So you can check that the first coordinate is 0 0 0, that is the origin one, and all the x coordinates are 0. And next this way, the along, as we have used our translation operation using our formula, so this way it is translated along x and y to get this square lattice. So this way we can generate square lattice. If you want any other lattice, this kind of formulas you can try for your definition of square or hexagonal or any other different lattices, so that you can build it by writing by writing very simple code. So this way we can write. And this much for today's session, and thank you all.